All right, so we're going to take some notes. We're taking notes on Pythagorean triples. Pythagorean triples are our focus. Our essential question today is, how do I use Pythagorean triples to solve problems faster? So again, we're trying to answer the question, how do I use Pythagorean triples to solve problems faster? You've previously learned that when two sides of a right triangle are known, the third side can be found using the Pythagorean theorem. It doesn't matter if that unknown third side is a leg or a hypotenuse. You can still use the formula a squared plus b squared equals c squared in order to find a missing side on a right triangle. When we learned Pythagorean theorem yesterday, I told you to focus on really what does A represent? It represents a leg. So leg squared plus leg squared equals hypotenuse squared. This is where I want you to focus your energy, right here. So, we've already previewed Pythagorean triples and what they mean, what they are. Any group of three positive integers, a, b, and c, such that a squared plus b squared equals c squared. Any group of positive integers that satisfy the Pythagorean theorem, that makes a true statement. The key word here is integers. Integers are whole numbers, as in not fractions, nor radicals. So it says, is 3, 4, 5 a Pythagorean triple? So what it's really asking is, does 3, 4, 5 satisfy a squared plus b squared equals c squared? If I use 3, 4, and 5 in here, does it actually equal c squared? So if we're looking at these numbers 3, 4, and 5, what is my a? Well, it's going to be the smallest number, so 3. 3 squared plus 4 squared, does it equal 5 squared? Well, let's check. 3 squared is 9. 9 plus 16, because 4 squared is 16. Does it equal 25? Well, 9 plus 16 does, in fact, equal 25. So is it a Pythagorean triple? Yes. 3, 4, and 5 are all whole numbers. In fact, 3, 4, 5 is the most popular Pythagorean triple. Now, what makes Pythagorean triple so special is that not only is 3, 4, and 5 a triple, I want you to think of it as 3x, 4x, 5x. What this is setting us up for is this is a ratio of sides. Or another thing this is setting us up for is similar right triangles. So if you have a 3, 4, 5 triangle, that means that any triangle that's similar all similar triangles can be solved for without Pythagorean theorem. We'll talk more about that right now. So the reason I put X and the reason we think of similar triangles is that, remember, similar triangles are triangles that are the same shape but a different size. And so you've heard of scale factors. So I want you to think of your X as your scale factor. So if I had this 3, 4, 5 right triangle, and we have another right triangle that, say, has sides 6 and 10. Well, you might recognize, well, 10 is just 5 times 2. 3 is just 6 times 2. We have a scale factor of 2. So if I were to ask you to solve for this third side, you wouldn't have to use Pythagorean theorem to solve for the third side. You wouldn't have to use that. All you would have to use is say, well, hey, 6 is a multiple of 3, 10 is a multiple of 5. That third side has to be a multiple of 4. In fact, it has to be 4 times 2. And we'll get 8. Now, you could have always used Pythagorean theorem to solve for that third side, and you would have gotten 8. But triples, noticing your patterns, will get you there faster. So, 3, 4, 5 is not the only kind of Pythagorean triple. There are many Pythagorean triples. Some of the most popular ones are 5, 12, and 13. If 13 is the longest side, that would be the hypotenuse. Another popular one is 8, 15, 17, 7, 24, 25, and 21, 20, and 29. All of these sets of integers satisfy the Pythagorean theorem. A squared plus b squared equals c squared. Now, not only do all of these numbers satisfy the Pythagorean theorem, not only are these triples, but any of their multiples. So if I multiply all of these integers by 2 or 3 or 5 or 6 or 7 or 8 or 11, I will still get a right triangle, and I can use that information to solve problems. So before we move on to the back, we're going to review some information. It says, recall that given 3 sides, a triangle can be formed only if the sum of the smaller 2, this is a little wonky, we're going to change that, is greater than the third. So in order for us to even have a triangle, A plus B needs to be greater than C. So using this recalled information, example 2 asks us, which of the following can be lengths of a triangle? Well, here we have 4 plus 5. Is that greater than 6? It is. So this can make a triangle. 4 plus 5. Is that greater than 9? It's not. So this would not form a triangle. 4 plus 5. Is that greater than 10? It's not. So this would not form a triangle. Now, we're also going to recall that one way to classify a triangle is by its angles. That one way to classify. A triangle can be acute, obtuse, or right. In fact, we're going to continue on with this example. This is the only one that formed a triangle, but we don't know what kind. We don't know if it's acute, obtuse, or right. Well, to classify, C comes first. But it's not plain C. We're going to square it and then compare it to A squared plus B squared. So in this set of numbers 4, 5, and 6, C is 6. So we have 6 squared, and we want to compare it to 4 squared plus 5 squared. 6 squared is 36, 4 squared is 16, and 5 squared is 25. 16 plus 25 is 41. 36, how does it compare to 41? Well, 36 is less than. C squared is less than A squared plus B squared. Therefore, we have an acute triangle. That's an acute triangle. So this is just reviewing. Example 2 is just reviewing. But back to this Pythagorean triples business. On the back, you're just going to be manipulating some Pythagorean triples. All you're going to do is multiply. So, for example, if we have the right triangle, 3, 4, 5, and if we multiply each side by 2, well then 3 would be 6, 4 multiplied by 2 is 8, and 5 multiplied by 2 is 10. What if we multiply these numbers by 5? Well, we would have 15, 20, and 25. That is what I want you to do for all of these problems. Once you've completed this, I want you to consider this your Pythagorean theorem cheat sheet. Use this to help you solve the Pythagorean stack right here. Use your cheat sheet to help you. Recognize patterns, look for multiples of 3, 4, 5, 7, 24, 25, and 5, 12, 13. So, email me if you have any questions. I will be here today after school for tutoring. I just might be a little late. Have a great rest of your day.